All right, guys. All right. All right. Yeah, my lovely viewers. Welcome to Frank Teaches MLOps. Yes, guys. So, in today's video, guys, I want us to look into NumPy. Yes, you got me right. NumPy. All right. So, NumPy is abbreviated numerical Python. All right. Let me leave it there. All right. Numerical Python. So NumPy um, is one of the libraries, one of the Python libraries that is used for numerical computation, mathematical and scientific computation in data science, machine learning, etc., etc. All right. So today I will be talking about NumPy in 60 minutes. NumPy in what? In 60 minutes. Yeah, you got me right. NumPy in 60 minutes. Yes, guys. That's our topic for today. So in the next 60 minutes, I will be done with NumPy. So NumPy is an acronym, all right? NumPy, which is numerical what? Python. So this gives birth to that. So let's put it there. Cool, 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 cool. All right. Now, what is NumPy? Let's take our time to define it properly. All right. So NumPy is a mathematical and scientific, right, computing library, right, for Python, programming. That's it. All right. So it is about a mathematical and scientific computing library. So meaning that if you need to perform any mathematical, scientific related task in Python, then the library suitable for such is what? NumPy. So what this means is that if we need to perform any mathematical, scientific related task, the rightful library for it is what? NumPy. Are we still recording? Great. Is NumPy. All right. So in the next 60 minutes or so, we will be looking at different, levels of NumPy, different levels that will get you into that stage where you will be comfortable, all right, to use NumPy in manipulating data sets, in manipulating mathematical data sets. All right. So yeah, all right. So we are getting there gradually. The next we have is what are the applications? Applications and uses of what? NumPy. What are the applications of NumPy? What are its applications? Right. So let's start with what is it actually used for? Right. So NumPy is used for or it's used to integrate complex numerical no numerical computing, right? Computing functions, all right, into Python code base. Python code base, right? That's the use case, right? Which you've already seen here. What is it actually? A mathematical and scientific computing mathematical, all right, library for Python programming. Now, what are the applications of NumPy? So applications of NumPy, it ranges from from the applications. All right. It ranges from what? Data manipulation, and analysis, right? Scientific computing, scientific computing, uh-huh. Machine learning, machine learning, all right? And signal processing of signals, and image processing, right? So these are few of the major areas where NumPy application is very, very suited, right? So that being said, this is just an introduction, okay? An introductory um, um, phase of NumPy, right? So now, sorry, I didn't show us what we're going to cover. Let me list what we're going to cover. So deliverables, deliverables, since too big, reduce it to, all right, that's okay, 10. So deliverables, what are my deliverables? These are my deliverables. One, introduction towards NumPy, which we are currently on. Then two, we shall look at NumPy arrays, right? NumPy arrays. Then three, we shall look at NumPy array indexing, right? This is how manipulating data, manipulating array elements, all right? Elements in an array. So array, images, pictures, audio, um, mathematical values, numbers could be presented, right? Or I would say images and signal, right? Could be video signal, audio signal, could be presented as in the form of numbers, all right? And to manipulate these numbers, all right, we use what? NumPy. And these numbers, they are arranged, right? They are being collected as what? Array. So your ability to index elements in an array using NumPy will actually set you a class apart in your journey into machine learning. I wouldn't want to talk about data science, all right? Yeah, because data scientists, they use this a lot. My drive is machine learning, all right? Because in course of going to machine learning, all right, you can't talk about data science without, we can't talk about machine learning without first understanding what are the tools you need to learn in what? In data science. All right. So there's a thin line between data science and machine learning. That will be a topic for another day. All right. So great. Then the last on that list, we shall also have NumPy array slicing notation. All right. And finally, we shall look at what? NumPy operations. So these are deliverables. So far we are still on what? Introduction to what? To NumPy. So in course of that, the next stage will be how to install NumPy. Installing NumPy is very simple, right? Now, the moment you've installed Python on your system or wherever, now you install, let's say, first install Python. Second, install a Python package manager, package manager, EIP. Install pip, right? Then finally, you use pip to install what? NumPy. Simple. You use pip to install NumPy, right? So now in this course, I'll be using Jupyter Notebook, right? Jupyter what? Notebook. And if you've not watched this my video, please go and rush this video, because this video will actually lead you into NumPy, this other content. Look at this video now. Right. So if you want to watch this video, Jupyter Notebook basics, deploying Jupyter Lab with Nginx as a reverse proxy. All right. So you have a lot to learn from this video. If you've not, please rush and watch this video. Once you finish watching the video, then you can come back, because in this video I won't be showing us how to install Jupyter Notebook from scratch. All right. So I already have Jupyter Notebook on my Mac. I'm using Mac. All right. So all I need to do is just to launch what? My Jupyter Lab. The moment I launch my Jupyter Lab, it's coming up. It's going to open a web-based browser IDE, all right, where I can start, my work. All right. So my Jupyter Lab is coming up. It's coming up. I just wait. Yep. So it's up. All right. So here's my Jupyter Lab. So on that video, like I said, on that video, I've also got talk about all of these. All right. So I won't be going over this again, right? So I've also shown how to navigate, how to use Jupyter Lab versus Jupyter Notebook. All right. So great, guys. So great. So now you can see our first. Let me close this video, right? Okay. So on our notes, we have it that how to install NumPy. So once all of these has been fulfilled, the Python has been installed, your PIP has been installed, then you can install what? NumPy. So let's just show us. You can install NumPy directly from your Jupyter Notebook. So I can say PIP install NumPy. To execute this, I'm going to press a shortcut, Shift Enter. All of these has already been taught in the video I just showed us. All right. So it says what? Requirements already satisfied, meaning that I've already installed this package. You may need to restart the kernel, blah, 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 blah. It's already installed on my machine, right? So there's no need of what? Reinstalling what? NumPy. Great, guys. Wait, now the next thing we need to do now is, how do you import NumPy? How do you start using NumPy within your Python, right? Within your what? Development environment, all right? So the next is how to import what? NumPy. Now, NumPy. Now, the easiest way to import NumPy, there is a Python syntax called import NumPy. So import NumPy means I have imported the library into my environment. All right. I can start using NumPy for development. Now I'll show us something. Now look at this now. If I come over here now and I'll say import NumPy, I execute that cell. Right. Now let's say I want to use NumPy to create an array. So I'll say NumPy dot array. Right. Let's say I'm creating a one-dimensional array. 1, 2, 3. And I hit enter. Not just enter, shift plus enter. You can see I have what? Created a one-dimensional array. But look at this now. There's a drawback, not really a drawback, but comfort, right? With just using NumPy as it is. All right, NumPy as in the library name as it is. Right now, I don't want to be using this library name. Rather, I want to create an alias. I want to create an alias for NumPy, meaning that I can still come back to cell 3 and say import NumPy as NP. But before I do that, let me show you something. If I come here and say np dot array blah 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 blah, I will have an error. It tells me that this name np is not defined, because I've not created this an array. Sorry, I've not created this an alias. So it means that instead of me to be using the keyword NumPy, I need to look for a literal in place. I can use in place of what? NumPy, and that literal is what we call what? Alias. And this is how you create an alias in Python. Import NumPy as NP. Now going forward, I won't be I won't be using NumPy. Rather, I'll be using what? The alias NP. So I will execute the cell and come here and I will execute the cell. You can see it is now what? Perfect. It is now what? Available. So this is how you import NumPy into your development, your Python development environment. All right. So that being said, let's now get started. So that was everything about what? Introduction. All right, introduction. So let's get started with what? Array, right? Let's get started with array. Great. Numpy arrays. So numpy arrays. So let me do this. That markdown, execute this. Great. Numpy what? Arrays. So now we will be looking, we'll start with what? How to create an array. So I can just say np.array. You use the array function. There's an array method you use in creating what? Array. All right. Now I want to create an array. Inside the array, I'm creating a list. Right. All right. Now in Python, we have two lists. We have the Python list and we have the NumPy list via array. Right. So this is a NumPy list. All right. So I say 1, 2, 3, 4, 5, 6. So I'm creating an array of 6 items, 6 elements. So shift enter, I execute the array. So this is a one-dimensional what? Array. So in here, let me come back to this markdown. Come back to this markdown. Oh, sorry, please. Come back to this markdown. So we look at 1D array. That's one-dimensional array. One-dimensional array. We shall also look at two-dimensional array. Two dimensional what? Array, right? So let's get started first. So I'll execute this as a markdown, shift enter, and we have that. All right, great guys. So this is just 1D, right? 1D. And let's also look at 2D. So in 2D dimension, I can say np dot array, all right, a function. Now I'll create list inside the list. So I'll say 1, 2, 3, right? Comma. I'll now say 4, 5, 6. All right. So yeah. So if I run this, I have an error. Yeah, because this is a 2D, so it has to be list, a nested list. All right. So I'll use another bracket, square bracket. Now look at this now. Within this, this is a single list. This is one list, and this is another list. Now, outside of this is one list. So in this array, we have about 3 lists. 1, 2, and the combination of the 2, 3. Right? So shift enter, we have a 2-dimensional array. How do you know if this is a 2-dimensional array? Now you can see, you can count the number of square brackets. This is 1 and this is 2. It tells you that there are what? This is a 2-dimensional what? Array. Unlike this is just a 1 square bracket, which means that it is a what? A 1-dimensional what? Array. Let's still check if I hope we're still recording. Perfect. Okay, great guys, great. So there are several common ways, all right, we can create NumPy arrays. All right, so we're going to go into that. So you've seen what a 1D is and a 2D array is. So that being said, let's look at common ways you can create, all right, a what? A NumPy array. All right, so there are common ways you can create NumPy array. The first is we have a range. So a range is a function. All right, we can look at a range. We can look at zeros. All right, we can look at zeros. We shall look at ones. I will explain all of that. We shall look at line space. A line space. I call it line space. Okay, we shall look at I. And let's keep it there for now. Now, what is a range? A range is a NumPy function. It is a what? NumPy function, right? Used for creating, all right, a distribution and even a distribution of what? Of numbers. A range. All right. Now let's look at zeros. Zeros, it is used to create an array of what? Of an array whose elements are all what are zeros, whose elements are zeros. Meaning that I want to create an array of zeros, all right? An array whose elements are all what? Zeros. We use the zero function, right? Once the same thing, right? Is used to create, let's copy this. It's used to create an array whose elements are all what? Ones. Then linspace, all right, is used to create an evenly distributed array. Is used to create an evenly distributed array of numbers or array of elements. Array of numbers, array elements. The items in an array are elements, all right? Then all right, this is used to create an identity matrix. Now, in those days in our mathematical class, right, where we were taught a matrix, okay? So matrix is yeah, is an array of numbers arranged in rows and columns. An array of numbers arranged in rows of columns. Now you can see this is a typical example of a matrix. A typical example of matrix. So if I want to remove this array, I could come here and say dot values. Dot values, it will it can't dot, is it dot value dot value? All right, I can't pass that. Let's say, so let me assign this to a variable. If I assign that to a variable, right, let me assign that to a variable, then I say a dot value. Okay, it's not giving me that. Is it value dot or values? Says numpy array object has no attribute value. Okay, it doesn't have that values. All right, let's continue. I'm supposed to have, sorry, it's pandas that has it. Sorry, pandas that has it. All right, let's continue, guys. All right, I can clear up this cell. To clear up this cell, select the cell and click on delete on the far right. Right, it's gone. Right, so these are the what's it called, ways to create numpy arrays. There are lots of other ways, but we are still coming. These are few ways we just get started. So what I will do now is I will launch this as a markdown. All right, and I'm going to run that cell. So if I run that cell, I have something like this. Let's continue. So the first one is arrange. So I'll say npy dot arrange. Arrange what? Let me create a range of numbers, right? From, let's say, from 0 to 10, right? From 0 to 10, and I hit enter. So it gives me a one-dimensional array of from 0 to 11, so to 10. Now, in total, these are 11 numbers, right? Because we have to start from 0. So I can change this. I can say from 1 to 10, right? So I have a number, it gives me from 1 to 9. So I have to from 1 to 11 in that case, right? This is from 1 to 10, right? So you can use a range. This is one-dimensional array. I can still use that arrange to create two-dimensional array. I can say np dot what? A range. I need 25 numbers, 25 numbers, right? Now, this, if I hit enter, it gives me these 25 numbers from 0 to 24. Let me just say 26. So it will, okay, from 0 to 24 is 25 numbers. Now, this is one dimensional. So for me to convert this into two dimensional, I can say reshape this array element dot reshape. Reshape towards 5 by 5. 5 by 5 means I have 5 rows, 5 columns. Reshape it towards a 5 by 5 matrix. So I'll run this command. I have a two-dimensional array. You can see now, and I have what? 2D. With the help of this arrange, I can, you know, I can conveniently, all right, create a distribution of numbers, right? A distribution of numbers. Now I can change the structure from 1D to what? To 2D. Okay, can see from 1D1 to 2D with the help of what? Another method that is in what? In NumPy, which is reshape, right? So you can do a lot of things. You can come here and say, okay, let's create 50 numbers and reshape it to what? 5 by 10. 5 by 10, 5 rows, 10 columns. We have all of these, right? So let's go forward, man. Let's go forward. So next on the list is what? Zeros. I can actually create a distribution of zeros. So I can say np np zeros, np zeros, I'll say, let me see, a division of 5, right? All 5 zeros, right? So I can go further and I would say, let's say 10. All the items in the elements is 10. And I can also create a two-dimensional array from all zeros. So I can say 25, I can say 6 and dot reshape. Reshape to what? 2 comma 3. That's 2 rows and 3 columns. I'll have these 2 rows and what? 3 columns. Right? So that is it, guys. Right? So the next is stop. Okay. Okay, so next on the list is ones. All right, so I need to create an array of elements where all the elements in that array are ones. All right, I just one. So I'll say mp dot ones, mp dot ones. Okay, so let's say same thing. I can say 5, right? So this gives me a one-dimensional array. So if I need to convert this into a 2D, I can say let me say let me see 25, then dot reshape into 5 comma 5, and there we have it, all ones. All right, all ones. So the next is a link space. So links, what link space does is link space, it's a function, a method that is used to evenly distribute array number elements, right? So for instance, now I say np.linspace, right? So now there is a help document, all right? Help document for all of these functions, all right? How to access a kind of a man page, a help document for these functions. If you don't actually know how to use these functions, all right, there is a help page. So the help page is, I want to access the help page from my keyboard. I'll say shift. While my hand is on shift, I'll press the tab key. When I press the tab key, I'll see this pop up. This thing comes up. Similarly, I can do that with let's say is it reshape? Shift tab key. It's not coming up. Let me remove this. Reshape, shift tab key. It doesn't come up, right? 2 command 3. Let me the real function, all right? Shift tab key, right? Now you can see the format of this method. It says these are parameters um can pass into what? This method. The start number, the end number, all right? And the number of elements you want, in that distribution. Then yeah, so let's try it and see. So let's say I need numbers between 0 and 100, numbers between 0 and 100. So if I hit enter, I'll have all of these. So these are numbers between what? 0 and 100. So you can see the last number is 100. Now if I want to evenly space these numbers by 10, then I'll have 10, 0, 10, 20, 30, 40, just like that. I can hit enter. So you can see I have 0, all right, 11, 22, 33, up to what? 100. So these are numbers between 0 and 100, but they are evenly spaced. Their spacing is by 10, right? By 10. So 0 plus 10 gives us 11. the first is 0, second is 11, and just like that. All right. The next 11 is 22, next 11, 33, until you get to what? 100. All right. So that's how to use linked space. Right. Now, the last on that list will now be I. So I, like we said, is used to create an identity matrix. So I'll come here and say np dot I. I of what? I want to create an identity matrix. The matrix must be there's a kind of matrix called an even matrix. Even matrix is a matrix where the rows and columns are equal. 4 by 4, 2 by 2, 5 by 5. Right, so these are even metrics. So I can just say 4. So this will give me identity matrix where the diagonal matrix is 1. So an identity matrix, wait, you need to create an identity matrix. So what is an identity matrix? An identity matrix, it is a matrix, right, where the diagonal element is what? Is 1, right? So that is, let's execute that. So that is what an identity matrix is all about. And to create an identity matrix, we use what? The method I. All right. We use the method I. All right, guys. So um that was the I method, which we use to create what? Identity metrics. So if you want, if let's see now, if I create, do it 5, I'll have an error. Okay, it went through. So this gives me what? 5 by 5. So what this means is what? 5 by 5. Okay, and that's automatic. 6 by 6, and the list and the array keeps growing, right? So if I say just 1, let's see if that works. So just a single element. So this identity matrix comes in what? In 2D, right? Comes in what? In 2D. Great. So the next on our list, is arrays of random numbers. So these are sets of methods, all right, that you could use to randomly, right, to randomly generate um a distribution of numbers. All right. So we have some few, oh sorry, we have some few functions like random within random there is all called rand. There's rand. We have random dot rand not n, and random dot ran integer. All right. So these are few we'll be looking at. Okay. So let me run this as a markup. Let me run this as a markup. All right. Great. So arrays of what? Random numbers. So let's now start digging. So np dot random dot ran. So this will randomly, let's say I want to randomly generate 10 numbers. Right. 10 numbers. So this by default, the data type for this rand is the data type of this for this rand is float. All right. Now let me show something. So I can use my shift tab. My shift tab will display the function. Sorry, the document, right? The help page. Let me call it the help page. The help page for that method. All right. All right. So it says random values in a given shape. This is a convenience function for users porting code from MATLAB and wraps random sample. That function takes a tuple to specify the size, blah 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 blah. Then here's the example, right? So I'm creating a 2D array, or randomly creating a 2D array of 3 rows and 2 columns, right? 3 rows and 2 columns. You can see So they create random numbers, random, right? But the data type here is float. Let me see the values. So it's not actually there. All right. So with the rand, you can actually create random numbers. So if I run this again, this was let me say 5, right? And so these are randomly 5 random numbers. So if I run this cell again, it will change those values. Shift enter. So you can see those values are changing. This is 0.018. Rerun it again. It changes 0.850. That's how these numbers will keep randomly changing, right? So that's a run. So let's quickly look into what the random n. They want to behave the same way. Rand n. So let's look how this is done. So same thing, same thing. So a return is sampled from a standard normal distribution, right? It's a convenience function for users porting code from MATLAB. Same thing, guys. All right. But let's look at this. Is done. Random n. So let's get started. So without any number, we can generate a value. All right. We can randomly generate a value, random number. Randomly generate the value. So let's see how can pass a tuple. You can say let's say 5, right? So these are single dimensional array. So you can see the same style we got here, same style we are getting here, right? Now, but however, these are randomly generating floating point numbers. Floating point numbers. Take note, guys. Floating point numbers. Now, the last on that list is random integer. So I can say mp.ran random.rand int. So rand int, I can randomly generate numbers between 0 and 5, right? So let me now pass a tuple. Let's say 0, 5. So the lowest, okay, this guy has a pattern. Now, the pattern here is the the format. It takes the lower value, all right, the n value. All right, but let's check to be very sure. So I say shift tab. So shift tab, now it takes a low value, right? It takes a high value, then it takes a size. Now I can come here and say between 0 and 10. I want to randomly generate numbers between 0 and 10 of a size of 50. Of a size of 50. So if I hit shift enter, I have randomly generated numbers between 0 and 10, where the distribution, the size should be what? 50. So it will just create numbers, a distribution of numbers from 0 to 10 randomly. All right. So you can see, and these numbers are 50 number. I can reduce it to 20. All right. So from 2, these, they are all 20 in numbers. As you can see, if we go back, if we go back to the documents, right? So see that the first item on that the low item, right? The second parameter to pass is a high value. Then the size of the distribution. What's the size? You can see by default the data type is what? Is an integer. So randomly generated numbers, integer numbers. So you use what? The rand int, right? Where you can specify the low number, the high number, and the size of the distribution, right? So similar, generally, you can just say, okay, I need to generate random number between 0 and 10. All right. It takes, if I click again, you can see now it's randomly generating numbers for me. It will never pass, it will never go beyond 10, right? Between 0 and what? 10. This is low, right? So if I now say, okay, give me between 0 and 10, where the size should be what? 5, right? If I run this again to change the distribution, if I run it again, it changes the distribution. So that's how it keeps changing distribution. So as the name goes, random, it randomly generates numbers in a given distribution. So that was that about arrays of random numbers, right? arrays of random numbers. So let's now start doing some manipulation, right? So let me put this back to 20. I need an array of 20 numbers. So in this list, okay, let me keep it close, 10. From 1 to 10, from 1 to 10, right? So now there are other functions we can also, other useful functions. I can say other numpy useful functions, right? So we have them. We've already seen reshape. We've seen reshape function, and we're going to be seeing maximum. So maximum is used to find the maximum elements in an array. All right. So this is used to find, all right, the maximum element of an array, what array. So the next we have minimum, all right, same thing, but this is just minimum. The minimum of an array. Then we have arguments maximum, right? This is used to find the index of the maximum elements in an array. So when we say index, we mean the position. Oh, we're still recording. The position, right? The position index is the position, aka position. Position of the maximum elements in an array. Then the last but not the least is argument mean, right? So this is the opposite. Copy. So this is used to find the index position of the minimum elements. The minimum meaning minimum elements in an array. So let's run this as a markdown, and execute. Great. So we've seen a reshape. Now let's look at maximum. So I have this array. So let me assign this a variable. Let me give it a. A is that, right? I run that cell. I come over here now. If I need a, it displays the content of that array, right? So this is assigned to a. So in this list of distribution, all right, I want to find the maximum value, right? I can say a dot max, right? And it gives me the maximum value here is what? Is 9. Maximum is 9 in this distribution, right? So I want to find a minimum. I can say a dot min. The minimum here is what? Is 1. Now I want to find the position of the maximum value. The position, you can see now these are indexed. This is a numpy list, all right, a numpy array list. And array, the items, the elements in an array are already positioned. This is in position 0, this is position 1, position 2, position 3, 4, 5, 6, 7, and so on and so forth, right? So I want to find the position of the maximum elements in this array. So I'll say a dot argument max. It gives me the position is 3. 6 is 0, 1 is 1, 3 is 2, and 9 is 3. That's the position of what? The maximum value. So if I want to find a minimum value, the minimum value here is what? Is 1. So the position will be what? 0, it will be 1. So I'll say a dot argument mean. It returns what? 1. So these are little functions that are going to help us in our journey into understanding NumPy, right? And eventually, which will eventually evolve into understanding machine learning proper, and the different application of NumPy, like in areas of signal processing, image processing, machine learning, scientific computation, as well as data manipulation and analysis. All right, so great, guys. So what do we still have in our whiteboard? So we've seen NumPy array. So next is NumPy array indexing. So indexing is a way of um okay, of picking the positions of array elements. Now let me bring back this A. So this is the element in this array A. All right. So now if I want to grab the value of the position of this guy, this 8, if I want to grab this 8, I'll target the position. The position of this item 8 will be 0, 1, 2, 3, 4, 5, 6, 7 is 8, is even 8. All right. So let's grab this guy. This will be 9. So I will say A of 9. So this is how you target in the positional elements, right? Using index. So this method is index, right? So this is going to what? Display the position of this index value. This index position 9, what's the value on that position? What's the value in that position? The value in that position 9 is what? Is 4. So if I hit shift enter, it returns what? 4. Similarly, I can grab the first element in this array. So I can say A of 0. Now the first item in that array is 0. The index position is 0, right? Which is what? 6. And so on and so forth, guys. All right? And so on and so forth. So if I want to grab what's the element at position 5, index 5, I'll have 6. 0, 1, 2, 3, 4, 5, 6. Oh, sorry. 0, 1, 2, 3, 4, 5. Position 5, right? Position 7. Position 7, we have 3, right? So this, I'm supposed to mention that. So this is Numpy array indexing, all right? Numpy array indexing. So let's mark that down, mark it down, execute the cell, right? So yeah, okay. So we can also grab a range of elements, right? So they call it array slicing notation, right? So that's called array slicing notation, right? Let's quickly mark that as a markdown and execute. So in array slicing location, let's call back our A. Our A is this. So now if I want to grab items, elements from 0, 1, 2, 3, from 9 to the end, all right, I could say, okay, I could say, let's say I want to drag 1 and 3. I would say A column position 0, 1, 1, all right, 0, this is 0, this is 1, this is 2. So I want to bring out element 139, right? So I'll say 0, 1, 0, 1, 2, 3, 4. So I'll say from 1 to 4, for one column 4, I need the items in that array. I need what? The items in that what? In that array. So you can see, with the help of slicing, I am able to what? To pick items in an array within a range, right? So similarly, if I want to grab maybe from this guy to the end, I'll come here and I'll say 3 to the end, right? I won't mention anything. So so this is what position is this? What index position is this? This is 0, 1, 2, 3, 4, 5, 6, 7. From 7 to the end. Position 7 to the end. I grabs 8, 3, 8, 4. So this is how you use the concept of slicing notation to filter elements of an array. All right. So we shall see how we will also employ the slicing notation in two-dimensional array. All right. The slicing notation in what? Two-dimensional array. So let's quickly look into 2D arrays, right? And see how we can start manipulating and making selection, right? So the next one is array slicing, okay, which is array slicing notation. So in this context now, right, let's create 2D array. So I'll say b empty. I want to create I want to create a distribution of about 25 numbers using a arrange. So arrange so I need 25. All right. So if I do this, b I have 25 numbers. This is just a single dimensional array, one dimensional array. Now I want to what? Reshape it to what? So if I say reshape, it gives me a 5 by 5. So 5 comma 5. So this gives me that. All right. So this gives me that. Okay. So now I have what? A a two-dimensional array where we have 5 rows and 5 columns. So this will really test our ability of what? Array slicing notation, to test our knowledge. Now, using slicing notation in a one-dimensional array is very easy, simple, straight to the point. All right, very simple. However, when it now comes to a matrix, a 2D, two-dimensional array, all right? So in two-dimensional array, right, it's always very, you know, critical and technical, all right? So if you don't understand the flow. Now look at this now. This is a matrix. Assuming now you are asked to select this section 18, 19, 23, 24 as a one matrix. As in all of these will become what? One matrix, a 2 by 2 matrix. How do you do that? But before we do that, let's take us through the basic, the foundational block of understanding slicing notation. All right, of understanding what a slicing notation. So let's go there. I should have said that from this beginning, but notwithstanding, there's enough time. So I'll say b into start index. Guys, watch. Start index, column, end index. End, or I call it a stopping index. End index. Now, what does this mean? All right. Now let's give us an example. Oh, sorry, you can't run this. Let me comment it out. All right, it's a comment. The syntax is what? The array variable, square bracket, the start index, column, the end index. All right. Now let's comment. So I'll say b square bracket. Now I need to display the entire row. So you can see now these items are arranged in rows and columns. All right. So let me bring these guys out so that you understand this thing properly, because you need to understand this properly. Great. So you need to understand this properly. So now look at this now. All right. So let me, great, great. Now look at, let me use my arrow, straight arrows. All right. So copy this, paste, copy, paste. And finally, the last one. All right. So this is the index of, these are columns, right? So say these are columns. These are columns. Column. All right. So these are what? Columns. And this side are rows. Oh, correct. So these are rows. So we have row 1. We have row 1. Whoa. You have row 1, you have row 2, we have row 3 and row 4, and finally we have row 5. Great. Right? So these are rows. These are rows. Oh, sorry. So these are what? Rows. Right? So now these rows and columns, they have their index positions. Right? So you have 0. The position of this row is, of this column, sorry, this is position 0. All right. So this is position 1. This is 1. So this is 2. And that is 3. And the last is 4. Great. Okay. Likewise, we have the rows. All right. So let me bring up these guys, copy and paste, rotate. Oh. It's not the way I want it. It's not the way I want it. So 0, we have 1, we have 2, we have 3. So I want to take my time for you to understand this very well, because it took me some time in understanding slicing. And slicing is very key. It's very key in your journey into machine learning, data science, etc. etc. Look at this now. Now, this column is column 0, column 1, column 2, column 3, column 4. Now, this row is row 1, row 2, row 3, row 4, and row 4, sorry, row 5, row 0, 1, 2, 3, 4. All right. Now, if I need this item, it will be an intersection. If I need this item in this position, it will be row 0, which is the start D, sorry, B of start index, column, end index. Right. All right. So this a different scenario. All right. So to target these elements here in this array, in this matrix, to be an intersection of rows and column, So let's go there now. So if I come here, if I need that item, this 0 now, it will be B of 0, 0. So 0, 0 gives me 0, because the first element in that matrix array is 0. Similarly, if I need to target 24, 24 will be what? Row 4, column 4. So row 4, column 4 gives me the item 24. Now, what if I need to target 18? So this will be what? Row 3, right? Row 3, column 3. So I say row 3, column 3, I have that value, right? So what if I want row 4, column 3? Let me check. Row 4, column 3, it gives me 23. So row 4, column 3, row 4, 0, 1, 2, 3 is 23. So this way, you can actually what? Target items, elements of a two-dimensional array, right? However, it becomes very complex when you need to what? Target, make a selection, a group selection, right? Let's say, for instance, I need to target 18, 19, 23, 24, so that it becomes an array, a 2 by 2 array. Similarly, if I need to target 12, 13, 17, 18, this is where it start becoming very complex. That is what I'll be teaching in what we've known as slicing notation. I hope we are still recording. Perfect. Slicing notation. All right. So now in the slicing notation, we're looking at start index and what? End index. Now, let's look at that. Now, before you target an internal, you make an internal selection. Now, I want to select 12, 13, 7, and 18 as one element. All right. Now, before you do this, you must divide the matrix into two. The simplest way, guys, the simplest way to achieve this, first, you divide this matrix into two. How do you do that? Now, you are going to first divide the rows, cut off the rows that you don't need. Now, you can see now, this is row 1. Let's come back here. This is row 0, row 1, row 2. The targeted items the items I'm targeting, they are in row 2. All right, they are in what? Row 2, 0, 1, 2. Okay, so it means that I'm going to cut off, I'll start my display from row 2 to the end. So what do? I'll come over here now. Oh, sorry guys. I'll say what? B row 2. Now, another thing again, aside these start index and end index, right? In dealing with rows and column slicing, right? So let me show us how the structure of row and column is. So the first item there is the row, column, the column. So that's the flow. So you first of all, you manipulate row manipulation, it gives you the row. Once you've gotten the row, you can go ahead to perform column manipulation. The first thing we need to do now, we need to perform what? A row manipulation. So in row manipulation, this is, I want to cut off row 0, row 1. So I want to start from row 2, display from row 2. So I'll come here, B row 2 column. Now, what this column means is that print out every element from row 2 to the end, from row 2 to the last row, right? So if I hit enter, I'll have this. You can see I have cut off row 0 and row 1. What I have now displayed is what? From row 2 to the end. I've performed what? The roll operation. Now I need to perform the column operation, which is 12, 13, 17, 18. So on which column is, which position is 12? 12 is in position 2, column 2, index 2. So I need this and this. So what I will do is, if I say 2 to 4, it will only print for me column 2 and 3 without including 4. That's how it works. So if I say 2 to the end, it prints everything. Let's try it and see. So if I come here and I'll say comma, right? Sorry, there should be a comma here. Comma. If I say comma, 2, column 2. I need from column 2 to the end. Column 2 to the end. I'll get this. You can see it included what? The last column. But I don't want to include this last column. I don't want to what? Include the last column. What should I do? I'll say from 2 to 4. 2 to 4, it will strip off the last column. So it will only print what? From 2, 0, 1, column 2, and column 3. It will strip off what? Column 4, the last column. All right, it's still off. But however, we need just this 12, 13, 17, 18. All right, 12, 13, 17, 18. What do we do here now? Let's think. You have to think, guys. All right. So I want okay, I want to print only, okay, I need this and this now. So this is from 2 2 2. This is okay. Let's go back to our whiteboard. So this is what row 2, row 2 to 4. All right, now row 2 to 4, it will print 2 and 3 without including what 4. Let's do that. So finally can come here and say 4. Enter. You can see I'm now able to stripe off this part, row 4, and I have what 12, 13, 17, 18. I've gotten what just this section. Now what if in this array I want 3, 4, 8, 9, 13, 14? How do we do that? Let's try it and see. So now, so I need that, right? So what will happen is I'm going to my rows. I will divide these rows into 2. First thing first, rows, please. So I need from 0 to what? If I say from 0 to the end, look at now. If I say from 0 to the end, it will print the entire matrix. All right. But I need from 0. This is 0, 1, 2, 3. From 0 to 3, we strip off the last row. We strip off the last 2 rows because what do I want? I want 3, 4. Abi, let's make it more difficult. I want 8, 9, 13, 14, 18, 19. Maybe you practice that, right? You practice that, right? So this is what I want: 3, 4, 8, 9, 13, 14. Now I'm done with what? Row manipulation, comma. I want to perform column manipulation. So now column, now 0 is just easy. 0, 1, 2, 3. 3 to the end. 3 to the end. I'll have just that, guys. All right, you can see how we are able to use slicing, array slicing notation to manipulate array elements. All right, perfectly. All right, I pray you're understanding this, guys. I just pray you are getting this. Now let's do one more exercise. Let's do one more exercise. All right, so I just need only this row, only this column: 1, 6, 11, 16, 25. All right, okay, 1, 6, 11. So let's do that quickly. So I'll say B, row first. I need all to be 0. So if I need all, sorry, all to the end, I have all the element, right? Great. Now column operations, comma. Now I want from 0 to 1. From 0 to 1, we'll print this first. From 0 to 1, will print for me just the first column. Let's try it. 0, column 1. If I hit enter, I have that first guy. Now I just need the second one. All right, so it will be 0, 1, 1 to 2, 1 to 2, and I'll get that. You can see the way I've been able to what? To filter out all of these row 1, to filter out what? Row 1. Now let's now see how we can do a summation of rows and columns. So now I want to sum up the entire rows. 0, 5, 10, 15, 20. What's the value? 1, 6, 11, 16, 21. What's the value? 2, 7, 12, 17, 22. What's the value? 3, 8, and all of that. So I just want to sum this array row column wise. So this is what I will do. I'll say B. All right, B dot sum. Sum has a function, right? Sum. Let's check the document. Okay, others. All right, or I can say numpy dot sum. Somewhere, sum which array? Sum this array B, sum the array. Now in this manipulation, right, in matrix manipulation, there are 2 axes. We have the column axis and the row axis. The column axis is identified by 0. Now to specify column axis, we say axis is equal to 0. So whenever you say axis is 0, it means you are referring to what? Column operations. Now if we say for row, axis is equal to 1, you're referring to what? Row operations. Let's go there. So look at this now. I say numpy.sum. I'm going to sum the entire array. All right, this array column wise. I'll now say axis is equal to 0. So what I'll get, if I hit enter, I'll get that the total of this column, this column, this column, this column, and this column gives us this value. Just do the calculation, guys. All right. Similarly, I can have the total of all the rows. So I can say np.sum of this array, comma, the axis is what? Is 1. Check it out. Enter. I have this. This plus this plus this gives you 10. This plus this plus this gives you 35. This plus this plus row wise gives you 60. This gives you 80, and this gives you what? 110. So you can see, guys, how we are playing around with what? NumPy slicing. We are churning array elements back and forth. All right. I think we are almost done, guys. We are almost done. We are almost done. Now, to wrap it up, we have what's it called on our list? NumPy operations. So guys, you can actually use this method, right, to perform some kind of matrix multiplication, addition. Let's say, for instance, now I have an array np.aarrange. All right, I have I need to display, or let me create an array np.array. Let's say 1 2 3 as one element, as one list, sorry, comma 4 5 6 as another list, then 7 8 9 as another list. So enter. I have an array of 3 by 3 matrix. 3 by what? 3 matrix. Okay, great. So in here now, I want to do what's it called? I want to bring out the different metrics I can have in this array. So you can see I can have, this is a 1 matrix. Let's say this is, let's call this A. This is A. Can display A, right? Now from A, I want to have B. 1 2 4 5 is 1 matrix. 2 3 5 6 is another matrix. 4 5 7 8 is another matrix. 5 6 8 9 is another matrix. 1 2 3 4 5 6 is another matrix. 4 5 7 4 5 6 7 8 9 is another matrix. So let's use this to end up this session, right? So now I will say A of, all right, 0 to 0 1 2 to 2. I have this. I've divided this matrix, right? I will have this as 1 1 2 3 4 5 6, right? So let me, I'll come back there later. I just need 1 2 4 5 2 3 4 5 4 6 5 6, sorry. So I have this. So I need 1 2 4 5. So 1 2 4 5. So I now have comma column. So 0 to 2. So I have this. So let me give it this as B. B is that. So we can have B, display B. B is that. Now C, right? So I need 2 3 5 6. So I will come here and say A of 2 3, right? So I want to start from 0 1, from 1 to the end. From 1 to the end gives me what? Gives me, sorry, that's row. Sorry guys, that's row. 2 3 5 6. So same 0 0 0 to 0 1 to 1. I'm sorry, 0 to 2 0 to 2. We've divided it. So I need 2 3 5 6. So 3 3 5 6, comma. Now I need 0 1 from 1 to the end. That's column. I have that 2 3 5 6. So we've gotten C. Then D. So D will be A of I need 4578. 4578. So I will say from 1 to the end, that's column. Sorry, that's row. That's row operation. All right. That's row operation. 45. I've divided it. Now I need now 45. So my column operation now will be all right 0 to 2. All right. 0 to 0, 1, 2 to 2 without including 2. I have 4, 5, 7, 8. Okay. So now I need 5, 6, 8, 9. All right. So same. So I have E, A, B, C, D, E. E is A of one column this. I have, let's put that at E, right? So I need 5, 6, 8, 9. So 5, 6, 8, 9. So what will be our column value? So column value will be from 1 to the end. I have 5, 6, 8, 9. Right? So that's E. So you guys, you can see. So that let's now split. We've gotten how many? 4 metrics so far. There are 6 metrics in this entire. There are 7, including the original metrics. Right? I want to bring out the entire 7 metrics. There are more than even. There are 10. I'll bring it all out. All right. So let's bring everything out. So let's now say F. F is equal to A of, all right. Print F, please. F. So F is this 4, 5. Okay, let me say 0. 0 to 1. 0 to 2, sorry. 0 to 2. I have 1, 2, 3, 4, 5, 6. Now, let me see the E F G. G is A of 1 to the end. All right. Sorry, it's printer G. I have 4, 5, 6, 7, 8, 9. All right. So we've gotten that. We split this guy. We've also split what? This guy. So how many metrics have we gotten so far? We've gotten 1, 2, 3, 4, 5, 6. Now we need, these are metrics as well. 1, 2, 3 are metrics. 4, 5, 6 they are metrics. So I will say A B C D G, B C D E F G H. H of A of 0. 0 to the end. Right? I will have H printed. Oh, sorry. The row 0 to 2 rows. I need that 0. Wait, 0. Yes, just this 0 print out row 0. Row 0. ABC, yeah, G H I A of 1. I'll get that. All right. I'll have that. Then J, I'm gonna have J. J A of 2. I have J. All right. I have J 7, 8, 9. Now I also have the column wise, column metrics, right? The grade. So this is 0, 1. So I'll now say, yeah, G I J K K of, okay. So I'll say A of, right? Let me see, this comma 0. Let me see, this will fly. Print that K. Print that K. All right. So 147. So 147. Okay, it's presenting it as okay, this. So let's see. Okay, this now has to be a combination. All right. So a row. So our row, we've gone past that level. So let me bring out just A so that I will know what I'm doing. So I'll have a visibility. So A is this. So I need 147 as a column, not as a row. 147. So this is what I will do. All right. So row 0. All right. Then row this. I'm still getting that. 0, 1. So I need 0 to 1. All right. So I have 147. Okay. 0 to 1. 0 to 1 without printing 1. All right. So the next one, MN. All right. M and N. Right. So we have, A of, right, I Still on row 0, all right, column, comma, all right, 1 to 2. I'll have the second column, all right. Then finally n, all right, n, we complete n with okay, a into row 0, column, comma, I'm dealing with on row 0, all right. Then I'm now say what, 2, right, 2. Let's see. Okay, I don't want this. So 369. So this will be from 2 to the end. Let's see what happens there. Correct. 2 to the end. From 2 to the end, I have 369. You can see from this matrix, we've gotten a lot of metrics with the help of what, slicing. So guys, if you can perform this or this exercise, it will really make you a champion in array slicing notation. All right, array slicing what, notation. So you can see from this matrix, I've spun up a lot of metrics: 1, 2, 3, 4, 5, 6, 7, 8, 9, including, okay, 9, 10, 11, 12, including the original metrics 13. Now here you can perform metrics and arithmetics, metrics addition, subtraction, multiplication, division. Now I can multiply m times n. I can say m times n to give me a value. So this is a multiplication of what, n metrics by what, m metrics. So give me what, this value. So you can perform metrics manipulation on your data. So guys, this is how you manipulate data in what, in using numpy, right, with the help of what, slicing notation. Guys, to wrap this session up, there are other what we call universal, right, universal array functions. I'm wrapping up, guys. Functions, right? Like I said, this is numpy in 60 minutes, right? Numpy in 60 minutes. Who yakata, right? So now there are other universal functions. We have the first one, you can say square root. We want to find square root, SQRT, right? We want to find maybe exponential. Maybe we want to find the maximum, which you've seen. We want to find other trigonometric operations, right? There are other trigonometric operations like sine, like cosine, cos, like logarithm. Those mathematical functions, all right? You can do all of that. So let me execute this as a markdown, all right? And do that. Here we are. So square root. So you can say, okay, mp.sqrt. What is square root of 4? Sorry, Baba. It gives us 2. All right, square root that, right? Exponential, mp.exponential, right? Exponential, that's, I have exponential, raised to power, not raised to power, exponential, right? You can have mp max sine, mp dot sine 30. We all know sine 30 to be, is it sine 30? Sine 30 is not supposed to be 0 points. Wait, okay, sine 60. Let me say 60, 0 0.5, 0 0.3, right? You can also get mp.cos, mp.cos 30. We have a value, all right? And so on and so forth, guys. You can get logarithm and all of that. Now, to see all of these mathematical functions in NumPy, in this library, let's do that. So now let's print all the mathematical functions. I'll come here and say print dir. Dir of what? NumPy. Now I want to print the directory of the library. It will show me all the functions in that I can use, right? In that what? In that library. So I'll run that. You can see a whole lot, guys. A whole lot in Yakpa. See all those zeros that we did. There's zeros here. And there's ones here. Right? So depend, Bobby, in plenty. There are so many. So this is how you get to know the functions that are supported by what? NumPy. With that being said, guys, at this juncture, I want to bring this session to a close. All right. That being said, I'm wrapping this session. Thank you, my lovely viewers. Thank you. Thank you. Don't forget to subscribe. To our channel. Like we said, we are moving into MLOps. All right. So gradually I'm dropping these things one after the other. So this is Numpy in 60 minutes. Thank you and see you in my next episode. Have a lovely evening.